This is Algebra 1B, Unit 1, comparing data sets. So first we're going to go over data distribution shapes, and if we look at this right here, you can kind of see the standard bell curve with these different things. This first one right here is a histogram, meaning like there's bars, like from 10 to 20 is a range or a bar. 20 to 30 is like a bar, so they group stuff together, and that's a histogram. This one over here is a dot plot. So every time there's a number 10, there's a dot for it. So this means there's 3 separate countings of 10. Here there's 1, 2, 3, 4 separate countings of 20. And then this graph is a box and whisker plot, and the line in the middle is the median, the number in the middle. So it's 30, and here's the number in the middle is 30, and also this one, the number in the middle is 30. And then we have like our outliers. Our smallest number is 10, and our largest number is 50. So that's the same here and here, same here and here. And then this also shows the interquartile ranges. So 20 and 40, their interquartile range was is the same with these graphs as well. So these 3 graphs are showing the same data, just in different graph formats. Okay. So there is here we have 3 graph formats: a histogram, a dot plot, and a box and whisker plot. Is showing the same data, and it's asking if it's skewed left or right. And I always have to think of this backwards. These are more leaning to the right, so they're skewed left, meaning like the tail, the low end of it is to the left. So these are skewed left. The majority of the data is on the right, and the mean or the average is less than the median, and the box and whisker shows the median in it, which is 50. I think if you were to add up all of these numbers and divide by the total number to get the mean, it would be 48. So this is skewed left. Down here, this one, these 3 graphs are showing all of the same data again, and this is what skewed right looks like. So the skew is basically like the tail where there's low numbers of data. And in this case, the median is at 30. And if you were to add up all of the numbers, like 10 plus 10 plus 10 plus 10 plus 20 plus 20 plus 20 plus 20 plus 30 plus, okay, you get it. And then divide by the total number of dots that there are, you get the mean or the average, and that would be 31 point something. So in this case, the mean or the average is less than the median or the number in the middle. So expect for the mean to be on the side of the skew, if that makes sense. Okay, so here we have an example. And they want us to find the mean and the median. So if I'm looking at this symmetric example, it lists all of the numbers in order from least to greatest. And then it shows a graph of it. And you can see this kind of follows the bell curve shape. It's symmetric. Okay. So if I were to cross out the numbers, you know, on each side to try to get to the number in the middle, I could also count and do that, but basically the numbers in the middle are 7. So the median is 7. Okay, like the number in the middle is 7 right here. And then the average, if I were to add up all of these numbers and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I were to add up all of the numbers and then divide by 16, I think I'm also going to get 7. So I'm going to use my calculator really fast. 4 plus 5 plus 6 plus 6 plus 1, 2, 3, 4, 5, 6, 42 plus 24 plus 9 plus 10. 106 divided by 16. Oh. I think I made a mistake. I'm going to add again. $112 divided by 16 is 7. So it's good to double check your work. So here the mean, the average is the same as the median. Okay, so for this next example where it is skewed left, meaning the majority of the data is on the right, and it has a tail on the left. Our numbers are written in order from least to greatest. And if I were to find the number in the middle, the median, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 total numbers. So the median is going to be the average of the two numbers in the middle. So the median is going to be 6.5, which is right here. Okay. Median right there, 6.5. And then if I were to add up all these numbers and divide by 10, so 4 plus 5 plus 18 for the 6s, plus 28 for the 7s, plus 8 is 63 divided by 10 is 6.3. So the mean is right here, 6.3. So as you can see, the mean is on the side of the tail. Like I mentioned before. And then for the other example over here, where it's skewed right, our numbers are written in order from least to greatest. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers again. And to get the median, we have to average the two numbers in the middle. So our median is going to be 7.5 right here. And then if we add up all the numbers and divide by 10, 6 plus 28 for the 7s, plus 24 for the 8s, plus 9, plus 10 is 77 divided by 10 gives us 7.7. So this one is the mean, and this one is the median. So again, the mean, the average is on the side of the skew or the tail. Okay, so here we're going to compare the data. And the symmetric one, the mean and the median are the same, and they're both 40, okay? Right in the middle. When we have a left skewed, the tail is to the left. The median, the number in the middle is 40, and that, 50, sorry. The number in the middle is 50, and then the average, the mean is 48. So that's to the side of the skew or the tail. And on the right skewed, the median is 30, the number in the middle is 30, and the mean is to the right of that. Okay, so here we have two separate graphs, and the one on the left has a large spread of data, meaning there's like in between 1,000 and 2,000, there's 5 data points, and there's it looks like 7 data points here, and like it's pretty consistent. There's data points across all of the numbers, but if we look at the small spread, there's no data over here and there's no data over here. So it's like concentrated all in the middle. Okay, so here we have a box and whisker plot. And this line right here is the median, or the number in the middle. And then the next step to making one of these is, so the median in this example is at 40. The number in the middle is at 40. 10 is the lowest number, which is why there's a line right here. 70 is the highest number, which is why there's a number right here. And then the edges of the box are the first quartile and the third quartile. So when you're lining up all of your numbers, your data points, you basically are taking the number in the middle between the lowest number and this number to get the quartile number. And then you take the number in the middle between the median and the highest number to get this third quartile number. So most of your data is going to be within this box. And then the lowest and highest numbers are usually the outliers. Looking at that on a bell curve, your box, like if you were to draw this as a box and whisker plot, like this would be your box, this would be your median, and then it would go out from here. So the majority of the numbers are like under the bell in the bell curve, but in the box whisker plot graph, it would look like this.